Nobody reads a postmortem written like a police report. You know the ones, those dry, finger pointing documents that completely miss the point of why we even review incidents in the first place. Well, welcome to this explainer. Today, we're going to simulate a senior engineer mentoring a junior to turn a blame heavy narrative into an industry standard, blameless document that actually drives real system resilience. John pushed bad code to the payment server again, and QA missed the bug. Ouch. We've all seen, or let's be honest, maybe even written something exactly like this in the heat of the moment. But when you write an incident report that points fingers like this, you are completely killing psychological safety. If a culture of shaming takes over, your engineers are simply going to stop bringing issues to light out of sheer fear of punishment. And sweeping things under the rug is literally the exact opposite of what we want. So here's our roadmap for this explainer. We're going to cover the blameless mindset, tackle those sneaky language pitfalls, learn some essential IT English, break down the 5 core sections of a solid document, and then wrap it all up with a live demo of a 47-minute outage scenario. All right, section 1, the blameless mindset. Let's talk about moving past human error. This philosophy was heavily pioneered by Google's site reliability engineers and companies like Etsy. The absolute golden rule here is to be tough on content, soft on people. Basically, a blamelessly written postmortem assumes everyone involved had good intentions and did the best they could with the information they had at the time. You focus on the how instead of the who. Like, why did the system even allow a rational, well-intentioned engineer to make that mistake in the first place? Moving right along to section 2, language pitfalls. This is all about reframing blame into system focus. Reframing blame is literally all about vocabulary. Instead of that toxic individual blaming statement, John pushed bad code, we're going to shift to some clean, process-oriented IT English. A configuration change was deployed without adequate testing. See what we did there? We aren't judging John at all. We're hitting the nail on the head by identifying a flaw in the deployment pipeline itself. And here's another huge shift. Instead of stating someone maliciously or maybe lazily ignored an alert, we look at the actual environment. Alert fatigue contributed to a delayed response. We're acknowledging that a super high noise to signal ratio in the alerting system is the real culprit here, definitely not the overwhelmed engineer. Okay, section 3, IT English vocabulary. Let's open up the Senior Engineer's Dictionary. First up is cascading failure. This is an absolutely great phrase to describe when just one tiny drop, say a bad database query or a single server going down, ripples out and takes down multiple dependent services. It's basically a massive domino effect that just overwhelms the entire system architecture. Next, we have single point of failure. Now, this is exactly what we want to hunt down and completely eliminate. If a single database node or one network switch going offline brings your whole application to a grinding halt, yeah, you've got a single point of failure that absolutely needs an architectural review. Then there's mitigation. It is so crucial to understand that mitigation is just your short-term fix while the fire is actively burning. Think rolling back a deployment or rebooting a server just to temporarily clear memory. It stops the bleeding and reduces the blast radius, but, and this is key, it is very different from remediation, which is your long-term, permanent fix. Finally, an SLA breach. Simply put, this means we broke our formal service level agreement promise to the customer regarding uptime or performance. This term is a real game changer because it ties technical failures directly to the actual business impact. And honestly, that's exactly why hyper-accurate timelines and impact statements are required. Section 4, the 5 sections. Let's look at the actual anatomy of a document. Every single industry standard postmortem has got to contain these 5 sequential steps. You kick things off with a clear incident summary, then build a strict chronological timeline, dig way down with a root cause analysis, list out the broader contributing factors, and then wrap it all up with concrete action items. But before we actually write these out, please keep this quote from Google's VP of 24/7 Operations, Ben Traynor-Sloss, in mind. A postmortem without subsequent action is indistinguishable from no postmortem. Seriously, if we don't meticulously track and execute those action items at step 5, we're basically just signing a contract to have the exact same outage again next month. The whole reason this document exists is to generate those action items. Which brings us to section 5, the 47-minute outage. It's time for our live demo scenario.
So imagine we're opening up a completely blank Notion page or Google Doc right now for a payment service that just went down for 47 minutes. We always start with the incident summary. Notice the super clean IT English here. We are completely avoiding vague fluff like for a while or some users. Instead, we get right to the point. From 1742 to 1827 UTC, stopping 12% of users from checking out. It's concise and it's strictly factual. Next up is the timeline. Now, this needs to be a strictly chronological, fact-based sequence of events with exact timestamps. Think of it as a server log, not a bedtime story. It has to show the clear transition from detection to mitigation to full resolution. We lay it out clearly. At 1742, we had detection. At 1810, we deployed a manual patch to mitigate the bleeding. And by 1827, boom, we declared the incident resolved. Then we jump right into step 3, using the classic 5 whys technique for a root cause analysis. We start with the most obvious symptom. Why was there an outage? Well, the token expired. But we definitely don't stop there. We dig. Why did it expire? No tracking. Okay, why no tracking? It was configured manually. Well, why manual? Because there was no automation step in the onboarding guide. See that? We successfully bypassed the whole human error trap and found the actual systemic root cause, a totally missing step in our documentation and tooling. Finally, we lock in our action items. And notice how we are using a really strict table format for this. Every single task is categorized by its type, like is this meant to prevent a recurrence or just detect it faster next time? But here is the absolute most crucial part. Every single item has a specific owner assigned and a hard deadline. Without an owner and a date, an action item is literally just a wish that's going to gather dust in your backlog. To wrap up this explainer, I want to leave you with a real question to think about. If your team read your very last postmortem, would they feel blamed or would they feel empowered to build a more resilient system? Take a hard look at your own documentation. Does it foster a culture of fear or a culture of continuous, exciting learning? Take these frameworks we talked about today, reframe your language, and just see what you can rewrite today.